Landboards presents DIY Kitchen Under-Counter Lighting, the Constant Current Power Supply. In the last video we saw how greatly the LED brightness varies by when you adjust the power supply voltage. Here we adjust the voltage up and you can see how very bright and quickly the LEDs become, as well as monitoring the current. You can see that the current pretty quickly rises, and there's a limit to how far you should go with the current on the LEDs. If you take the current too high, it will burn out the LEDs. What we need is a circuit that will hold the current constant, and this is known as a constant current circuit. A quick search of Google Images turns up a decent looking constant current source. Let's take a look and see how it works. The link takes you to a site called Designing with LEDs, and the article is a hopeful title, Making a Constant Current Source LED Driver Out of a Voltage Regulator. Sounds reasonable. Let's take a look at what they do. Here's a circuit that they show. It's a little bit fuzzy on the website and on the picture. Let's look at the comments and see what they say. Well, now here's an interesting comment. You should have at least given credit to OnSemi's application note AND8109. Let's go look at that application note and see what it has on it. And sure enough, it looks like that website did borrow very heavily from AND8109/D. LED constant current source scheme. Let's take a look at their page and see what the schematic looks like there. The schematic shows three different LED chains, and it shows an adjustable voltage regulator, the LM317L, driving all of them with transistors driving each of the individual chains to keep them separate. Looks like that might do exactly what we want to do. Let's run an LTSpice simulation for the circuit and see how it performs. For our simulation, we're running the input voltage on V1 from 0 volts up to 15 volts, and the blue curve is showing the current through the LED chain. As you can see, the current stays at 0 until the input voltage reaches somewhere around 10 volts. Then it goes up pretty sharply, and then after a certain point stays flat, and it looks like the flat current is around 58 milliamps, give or take. I had to pick a particular value of LED since the default LED didn't work. It crashed the model. The flat part of the curve at the upper right blue is the desired effect. We want something that maintains a constant current above some voltage and doesn't vary the LED current with the input voltage, and this circuit looks like it'll work just fine. Let's look at it a little closer. Here we've zoomed in to the voltage input going from about 7.7 volts up to the 15 volts. To get a closer look at where the LEDs come on at. Looks like they start coming on fairly soon, somewhere around 8 or 9 volts, and it looks like they're on full stop somewhere around 12 volts. That's really exactly the circuit behavior that we want to run this off a 12 volt wall wart. Zooming in a little farther, we can see that the operation from 11 volts to 12 volts, and in particular we can see how nicely it's on by the time it's at 12 volts. So this looks really exactly like what we want. In part 3 we'll build the circuit on a breadboard and see how well it works. For more information, check out our wiki page. We also have a YouTube channel where you can learn how to use these products, and we sell our products on Tindy. Thanks for watching our video.